It is my honor and pleasure to introduce today's speaker, Mr. Peter Nelson. Mr. Peter Nelson is President and Chief Executive Officer, CEO of California Water Service Group, based here in San Jose. Mr. Nelson received his MBA degree from University of Massachusetts in Amherst and a bachelor's degree in mechanical engineering from UC Davis. Mr. Nelson has led California Water Service Group, CWS Group, for 14 years since 1996. CWS Group is the largest investor-owned water utility company west of Mississippi and is the third largest in the country with annual revenue of more than $400 million. It was founded in 1926. It provides water and wastewater utility services to about 2 million people. In addition to his leadership in business, Mr. Nelson is also active in professional and community organizations. These include the California Chamber of Commerce, the California Water Resources Committee, the Silicon Valley Manufacturing Group, American Leadership Forum, Joint Venture Silicon Valley Network, and the Tech Museum of Innovation. Now please join me in welcoming Mr. Peter Nelson, President and Chief Executive Officer of California Water Service Group.
Thank you very much. It is a pleasure to be here, and thank you for introducing me as an engineer, because the last time I was in an engineering group, I was out there, and cell phones were not an issue back then. So anyway, thanks for having me. It's my pleasure to be here on behalf of California Water Service Group and the entire water industry. I noticed some of your prior speakers were a lot of high-tech people have been speaking here, and I imagine that most of them were doing a little soft recruitment for their companies. I'm not going to do a soft recruitment. I'm going to do a hard recruitment today, because I'm going to ask you to consider the water industry and California Water Service as a possible career path where it may not have been obvious to you before. So soft sell? No. I'm going to make a pitch at the end to look at the water industry as a career. But first we'll talk about tap water, because before I joined California Water Service Group 14 years ago, I had no idea where my water came from. And I'm a Cal Water customer. I live in Menlo Park. I had no clue where the water came from, that it meets standards, or any of that. So we'll talk about the tap water business first, and then why it's critical, and we'll talk about the United States and about worldwide, why it's critical. Water problems and solutions, there's lots of problems, and there's lots of people working on solutions. We need more people. We need more talent. And I'll do my self-serving commercial. Thank you for starting it. But I'll talk about Cal Water, where we serve, what's important to us, where we're headquartered and all of that. And then we'll wrap with my pitch. And you already know what it is. So first, this is the only slide about the tap water system. So this is a typical pictorial of a tap water or drinking water systems. There's only two sources for tap water. Surface water, could be a stream, a river, a reservoir, a lake, could be ocean, and groundwater, aquifer. You pump water out of the ground, out of the aquifer to a wellhead, treat the water there, and pump it into the system. Obviously, surface water is major treatment plants. The Silicon Valley Water District, Santa Clara Valley Water District, I should know, has major treatment plants. Teche System, major treatment plants. Those are all over. So the water comes from two sources. It's treated at the plant or at the wellhead. We test for water quality at both of those places. We have 169 water quality standards we need to meet every day, every hour. And then after it's pumped into the system, we do test the water every day throughout the distribution system. We take samples every day, send it to our lab, and make sure that it meets all those 169 water quality standards. One thing most people don't recognize is that we also provide fire protection, fire plugs. In fact, from an engineering point of view, the system is really designed to provide fire flow, not customer demand. So this is a typical system. this is not like a gas system or electric system because water supply generally, since it's wells, water supply is local. So if you live in Chico, you're drinking water from the Chico wells. If you live in Los Altos, you're drinking water from Los Altos wells or maybe from the Santa Clara Valley Water District, purchased water. But it's a local business. The systems are not tied together. Although the conveyance systems, from say surface water to treatment or treatment to the distribution system, can be huge wholesale suppliers traveling hundreds of miles distance. The water that enters San Francisco comes from the valley north of Yosemite, the Hetchetty Valley, and travels some 250 miles between surface water and treatment. It's a beautiful system. There's not one pump in that system. So this is the usual normal orientation slide. I even show this to investors, potential investors, so they understand what the business is. So, moving on to why water is critical. Tap water is irreplaceable. You've had a lot of technology speakers. I can tell you there's no technology that's going to take over water. There's no substitute product. Bottled water, I don't know. It's the same product basically. So it's essential to life. You need water to survive. I think it's 3 days without water, a week or so without food. Water is essential to life. I mentioned fire protection. When you lose pressure in a water system, you lose fire protection. That's not good. And one thing we don't think about is that water is necessary for pretty much everything we eat or produce. Clothing, and I have a slide on this, food. Everything we consume or use in some way, shape, or form involves water at the source and in the process. Because this is a university, I will ask some questions. First question is, how many gallons of water does it take to produce a hamburger? Now, you don't shout out. Just in your mind, think about, okay, a hamburger, go back to the source. How many gallons of water would it take to produce the hamburger? Answer, 660 gallons. Now, obviously, there's not 660 gallons of water in the hamburger. Water is used to grow the crops that the cow or steer consumes. It's used in the manufacturing process. I'm going to guess the lettuce is part of this, so it takes water to produce the lettuce, but it takes a lot of water to produce a hamburger. Same kind of question. How about a pair of blue jeans? I'll give you a small hint. Cotton. We grow cotton in California. We grow cotton in the San Joaquin Valley. It's a very water-intensive crop. 1,800 gallons to produce one pair of blue jeans. That's amazing. And then my favorite. How many gallons does it take to produce a glass of beer? Grow the hops, grow the barley, do the manufacturing process. It takes 20 gallons of water to produce one glass of beer. So the point here is we're very intensive water use economy and people, obviously. Our way of life is centered around water and use of water, and there really is no substitute product here. You need water to live, survive, and for food and for clothing and everything else we use. So that's how critical water is, tap water is. Now, what are some of the challenges? And I'll kind of split these into U.S. and then worldwide challenges because they're a little different. First is obviously water quality. You want the water you consume to be safe to drink. So water quality is always a challenge, and I'll talk about each of these points a little later. And there's only a set amount of water on the earth. Nobody's producing more water. It's recycled through the hydrologic process, but the supply is fixed. And as the climate changes, it's going to present different challenges as far as planning and supply and conveyance. And we have aging infrastructure, not so much on the West Coast, but in the East Coast and in Europe. The infrastructure has been there for 100, 200, or 400 years in London. London's water system, believe it or not, leaks 40% of their supply into the ground. needs to be replaced. So aging is a huge challenge for Europe especially. So the first bullet point, water quality. The technology, and this is not that long ago, the technology, I would say 10, 15 years ago, in our lab, with the technology we had, the machines we had, we could detect 1 part per million of a constituent. Now we're detecting parts per billion. One of our standards is meet the iron limit, which is 300 parts per billion. Some of our constituents, the standard is 1 or 2 parts per billion. It's hard to imagine that. And we're moving towards parts per trillion, measuring that. So once you can measure something, you can set a standard. And you can test it to see what the public health effects are. So just by the fact that technology allows us to measure things at very small quantities does drive new water quality standards. Aquifers are always being contaminated, I'll say. And this is particularly a problem for us in the Salinas Valley, in the San Joaquin Valley, where agriculture has used pesticides, herbicides, any kind of thing they put on the soil leaches down into the aquifer. It can be very difficult, expensive to remove, or it can shut down the aquifer for water source. So we're always looking for new supply because aquifers are always deteriorating. And standards are changing. I mentioned that. As standards get more rigorous, the Environmental Protection Agency proposes new standards every 3 years. As there's more standards, it's more difficult to run this business, and we're always looking for new supplies, new treatment technologies, new conveyance systems. So water quality is critical. Next question. I mentioned a part per billion. I can never get my arms around that. How much is a part per billion? Those of you who've got calculators, you're going to get this right, I think. Is it 1 penny in $10 million? I see the math going in. A second in 32 years. 1 second in 32 years. Is that a part per billion? It's pretty small. How about this is my favorite, a blade of grass on a football field. The size of 1 blade of grass on a football field. Or is it a drop of water in an Olympic-sized pool, or is it all the above? It is all the above. These are different ways to measure it, but it's amazing how small 1 part per billion is. As I mentioned, we are measuring this, and we have standards set as low as 1 or 2 parts per billion of a constituent in the water system. And we're moving to parts per trillion. Imagine 1/1000th of a blade of grass on a football field. We'll be able to detect that and remove those from the water. It's amazing. Technology really drives water quality. So water supply. I mentioned the supply is finite. We're not making any more water, and it's a question of storing it, conveying it, using it efficiently. Climate change will exacerbate the water problems. In California, a lot of our storage of water is in the Sierra, Northern California and Eastern California. When it snows, that is a huge storage base for the state. And obviously it melts in the spring and early summer. We store that and use it all year round. California is unique because it only, as you know, rains or snows in the winter, and water is used all year round. Not like the East Coast. So if something happens to the snowpack over time, it doesn't have the same volume. If it melts early, melts late, that changes everything. It changes all the assumptions, all the storage assumptions and conveyance assumptions. There's competing interests, and I'll talk about this later, especially in California, because the supply is finite, economy is growing, people are coming into the state. There's always this competition, tug of war between people using water, industry to make blue jeans or beer, agriculture. Agriculture uses 80% of the usable water in the state. It's pretty typical of a farming state. So agriculture is the #1 business in California. It uses 80% of our water. And the environment. Surface water equals ecosystems. And you need to protect the environment, protect the ecosystems, and that requires water. Think of the salmon running up the Sacramento River into Battle Creek without water. Not going to happen. And communities have built where there's not much water. If you saw Chinatown, the entire LA basin is built and there's not enough water. Las Vegas, Phoenix, Scottsdale, Albuquerque. So we built communities where there's not enough water. That creates huge challenges to store it and convey it and sustain it. So, bringing this home to the Santa Clara Valley, when we first started to farm in the Santa Clara Valley, we pumped the aquifers, and we got a little carried away. So in some parts of the valley, there's been subsidence as you pump the water out. Did it subside 1 inch, 5 feet, 10 feet? I used to be good at multiple choice questions. 10 feet, obviously. That's been stabilized. The aquifer's been stabilized. We're now spreading water to let it go down to the aquifer so the aquifer is stable. We're not overpumping it anymore, overdrafting it. But nonetheless, in the early years of agriculture here, we overpumped this basin. More than 10 feet. So infrastructure is the third point, the third challenge. I mentioned aging infrastructure, primarily on the East Coast. And in Europe, developed countries, we do have pipes here that are 100 years old. Replacing them is important. And a lot of our water systems are using very old technology. It was mentioned that Cal Water is the largest water company in the western states. If I could go back, I'm not going to go back to the other slide, but if you think about the entire water business, go back to this first slide of what it looks like. 80% of the water business is owned and operated by public agencies. City of San Francisco has their own water department. City of Sunnyvale, City of Gilroy, they have their own water systems, their own water department, their own water organization and business. That's 80% of the business. 20% is privately owned and operated. We're an investor-owned company. You can buy our stock on the New York Stock Exchange, but we're the largest of the 20% in the western states. There are 55,000 separate water systems in the United States. 55,000. A lot of them too small, too undercapitalized, not invested in. So we've got a lot of systems out there, generally small cities, small areas, that have not invested in their infrastructure, and it's aging. They need to be replaced, refurbished, replaced, mainly. And I've got a slide on the state. It may be the next slide, but this is... The state of California has the most complex water system in the world, more complex than the Jordan River. To store water, convey it, and move it is very difficult in California. And I'm going to talk about the Delta because if you're a California resident, you really should know about the Delta. And you can read some things about it, but it can be very complicated. I can make this, and I will, very simple. So here's the state. I mentioned precipitation happens here in the Sierra, and the water, which is great, except the water is used on the coasts and in the southern part of the state. So you've got a challenge to move the supply west and south when it's landing in the northern part of the state. So this could be an entire semester's course, but I'm going to do this in 5 minutes. So the Sacramento River is the main conveyance facility for the state. Lake Shasta, Lake Oroville, all these rivers essentially feed into the Sacramento River and come south. The Sacramento River enters this area called the Delta, the San Francisco-San Joaquin Delta, where it's mixed. This is kind of a switching point, and either goes out to the ocean through the Golden Gate Bridge, or is pumped out at the bottom of the Delta through major pumps and 2 aqueducts. And actually Silicon Valley takes this water right there, and we drink it. So every person, or every organization or person south of Tracy basically gets water from the Delta. Half of all the runoff in the state goes through the Delta. 2/3 of this population drinks water from the Delta. So what is the Delta? It used to be a wetland, a marshland. Huge area, Stockton, Rio Vista, all that area, where the old San Joaquin River, which has been dry for a few years, and the Sacramento River mix together before it goes out to the ocean. Well, about 130, 40 years ago, we built levees to create farms in the delta. It's 1,000 miles of levees creating 60 farms in the delta, which is a problem, because now the water is not flowing the way it was designed to by nature. It's got to work its way around farms. Farms are pumping the water into their farm, pumping actually their wastewater back into the delta. You've got, unfortunately, wastewater treatment plants putting in here. It's a bad design. You're putting in very good quality water here. It's working its way through miles and miles of what are farms and levees to get to the takeout point in the south, where it's pumped out and sent south for use. This is a good example of the tug-of-war. You've got people who want to use this water here in Silicon Valley. Agriculture wants that water. They may or may not have rights to it. Industry uses that water, and especially the ecosystem needs that water. You've got many, many species, plants, animals, fish, some of which are endangered species that need water supply to survive. So you've got this tug-of-war, and this is very, very difficult for the state to figure this out. Every governor for the last 25 years has tried to solve this, has not solved it. On the 2012 ballot, you'll have the opportunity to vote for probably a $10 or $12 billion bond proposition to create a bond to solve this problem. Now, when our Governor Schwarzenegger, first saw this slide and was briefed the same way you are, his first question, which was brilliant. He says, why is the intake point here? Why isn't it up there? Why not move the intake point to where the good water is on the Sacramento River and control it? You can control the water going through the delta. You can get clean water going around here to the canals. Why not do that? That's the answer. That's called the peripheral canal. Take the water here, a tunnel, a canal, some kind of conveyance that goes around or through, dedicated to these aqueducts going south. That's the entire California water problem situation in 5 minutes. Got it? How are you going to vote? I'd say yes. On that bond also is going to be probably a pretty large storage facility here and a storage facility here. And the storage is really for the ecosystem. So you capture the water in wet years in the storage facility. In dry years, you release that into the delta for the ecosystem. So that's the California situation in 5 minutes. So, one more question. I talked about infrastructure investment. How much does the EPA estimate will need to be invested in water infrastructure in the next 20 years? This number's bounced around some, but the answer is a lot. They say $335 billion. I don't think they're even scratching the surface. We're talking $10 billion for California for one conveyance system and 2 storage facilities. So this is probably understated, but the point is there's going to be a lot of infrastructure invested in the water business over the next 20 years. So I've talked about the United States and Europe and California and the Bay Area. Our problems pale to what the problems are in the rest of the world. In the developing countries, in the underdeveloped world, essentially, they haven't moved anywhere in the last 2,000 years. The Romans, 2,000 years ago, had better sanitation, wastewater systems, and tap water systems than half the world does today. I wouldn't show you pictures because they are depressing about what it looks like in the developing countries and the underdeveloped world. 6,000 people a day, mostly children, by the way, die of a waterborne illness. And this is both wastewater, sanitation, and tap water. It's a big problem worldwide with having adequate wastewater facilities and then protecting the tap water sources from the wastewater effluent and treating the tap water to be safe to drink. So 6,000 people a day, and divide that by 24, you see how many people per hour are dying from a waterborne illness, all of which are preventable. This one this one is the one that got me, this one statistic. How many of the hospital beds that are filled with someone who has a water, in the world, are filled with someone who has a preventable waterborne illness? This is the one that floors me, 50%. Half the hospital beds in the world that are occupied are filled with someone with a preventable waterborne illness. There's a lot of opportunity outside the U.S. I think these problems are being worked on best by actually non-governmental organizations. Engineers Without Borders, Water for People, Save the Children. Universities all over are putting a lot of effort into worldwide water problems and solving this problem because it is depressingly all preventable. Now to solutions, and we could go on for hours and hours on solutions, and I just threw a few up here. And these are kind of a mixture of Bay Area, California, US, and world. So first, creative conservation and reuse. I think we've barely scratched the surface on conservation and water efficiency, especially in agriculture. And reuse means you take a wastewater treatment plant and treat the effluent to be usable for either irrigation or tap water. So we can go a long way, I think, more in conservation and reuse. If you go to Europe, you'll find that Europeans use about half the water per capita that we do. And they pay twice as much too, by the way. So that's a possible solution. Market incentives for water transfers. It's very difficult in California to transfer water or water rights from one place to another. If we could do that easier, it would free up agricultural users to sell their water into the public systems, private systems, or for the ecosystem. So there really isn't any incentives now. There's not a good way to do a market transfer for a farmer in Chico or Marysville to sell their water and it to be used in the Delta. That's very difficult to do now. And that's all basically politics, I'll say. Use private investment to upgrade infrastructure. I mentioned worldwide what the problems are. I would say the governments in developing, undeveloped countries have done a very poor job on this. So, to my mind, the public agencies in the US and the rest of the world really need the private investment, private expertise, and private capital as partners to help solve these problems and build this infrastructure and make it work. Silicon Valley type solutions, and I don't mean just computers and technology and digital, I mean treatment. If we can build better treatment systems to treat the water from the source, better treatment systems that can treat the aquifer, the contaminated aquifers, and do it cheaply, that'll make a big difference, huge difference to solve the problem, especially in the developing world. A lot of folks are working on how do you treat water in a small city, small town in India, for example. Not large scale, it's small scale. You need something small scale, good technology, and it's actually new technology to provide safe water for people around the world. And then worldwide, of course, expertise, money, and technology. We need everything. And there's a lot of good people working on the worldwide problems, scratching the surface. There's still half those hospital beds filled. So, I'll move on to my self-serving commercial, which is introduced very well. So, this overview of Cal Water, because generally people don't know who their water company is. These are the areas we serve. We serve 4 states. We have full operating systems, wells, treatment plants, surface water supply, watersheds in all 4 states. Our headquarters is up North 1st Street, just before you get to Highway 101, North 1st Street. We have about 200 people at headquarters, and these are mainly engineers, mainly the functional groups, engineering, computer technology, IT, accounting, business, finance. That's all at headquarters in San Jose. And then we have 1,000 employees that are spread out over our 4 states. And each of these dots is an area we serve. So in California, you see we serve all the way from Chico to Bakersfield and the Palos Verdes Peninsula, We have most of the peninsula here, San Francisco Peninsula, South San Francisco, San Mateo, San Carlos, Woodside, Portola Valley, Atherton, Menlo Park, Los Altos are all our systems. We're the largest water company in the western states. Obviously, the first and second largest are in the east. They don't serve out here. We're the third largest in the U.S. The fifth largest in the U.S. is a neighbor of ours, San Jose Water Company, and I'll mention them later. So you've got the third and the fifth largest U.S. water companies within a 15-minute drive of San Jose State. 1,000 employees. Strong connection to San Jose State. Are we going to beat Fresno State this weekend? God, it's a winnable game. It's a winnable game. Beat the Bulldogs. We sponsor each year a civil engineer scholarship. We have research partnerships with the school. We contribute to the canoe, the concrete canoe. So there's a strong connection, and of our officers, we have 9 vice presidents. 3 of the 9 are Spartan alumni. Chairman of the board, Spartan alumni, big-time football fan. So strong connection. We recruit a lot from San Jose State. Engineers, computer science, business majors, I mean, you name it, scientists, chemistry majors, all disciplines. You are our labor source, essentially. So we are looking all the time at San Jose State for talent. We pride ourselves, and I think most water companies would say this because the nature of the business is to protect the environment. We need to protect our aquifers, our watersheds, our water supply, and what we do is we take water out of the aquifers and surface water, make it safe to drink, and deliver it to people. I mean, it's a very environmentally conscious industry and a very sustainable industry. We need the water supply there for the infinite future. So we're planning ahead at least 20 years, and actually we plan to be in business at least 100 years. So we're looking at sources of water out 100 years. So we pride ourselves in being very sustainable and very environmentally conscious, very efficient. We are, as an investor-owned water company, we have the largest conservation program in the industry, larger than the first and second largest water companies. So we're very proud of that. Customers, of course, we produce excellent water quality for our customers. They're very happy. We measure service all the time. Communities, because we serve, it was mentioned 100 communities in California, and probably if you added in Washington, New Mexico, and Hawaii, there'd be 150 communities. It's important to us that have our local people be leaders in the community. So you see us very involved in community activities, leadership role, all over the state and in the 4 states we operate. And employees, we also pride ourselves on being the employer in the water business. That's preferred. We're very proud of our workplace climate. People come for a career. I mentioned to our investors our turnover ratio. We want people to come for a career because we want a real good corporate memory on all these systems. And it's hard to hire people at mid-career. I mentioned to our investors our turnover ratio, which they're interested in. Our turnover ratio is about a little less than 4%. That means we have very little turnover, very little churning in the system. Employees come for a career, and we expect a lot out of our employees. Expect them to make a big difference in the water business. These are also, we support our employees to get out and make a difference worldwide. And these are 3 of the projects that our employees have worked on worldwide, and we support them to do this. Pay their salaries while they're doing it. So the first one is, I'll talk about this one first. This is in Honduras. I think she's a Spartan alumni. Maybe not. Anyway, this is our employee here working on water systems, wastewater systems in Honduras, last summer or the summer before. Then I'll go top right. This is our design engineering manager in Tanzania. She went 2 summers and built wells and treatment for well supply in this village in Tanzania. She may be here today at the career fair, actually. Erin McCauley. And this is probably my favorite. These are not, I think both Erin and Shamala were Engineers Without Borders sponsored. So But this one, the two guys down here, they're not engineers. They're operating superintendents out of our Bakersfield and Visalia areas. And they spent some time in Uganda. And this is them early on in their visit entering the village. And you can see Eric has a bottle of water that we actually bottle in Bakersfield. We bottle our own bottled water. But this is early on in their project in Uganda, where they worked on hygiene, protecting the water source, treatment, and wastewater quality. And there's a lot to do. And so, and this is when they're leaving the village. So they made a few friends in the time they were there. So this is probably my favorite picture. Eric Charles and Bill Harper about to get in the truck and drive away, and you've got all these kids whose quality of life was improved because these two guys spent their time working on the water and wastewater systems. So here's the pitch. Cal Water is a great place to work. My pitch here, though, is to consider the water business, tap water business and the wastewater business, which is, to me, we have a small part of our business is wastewater. We own 10 or 12 wastewater plants. The effluents used for reuse for irrigation. Very technical. Actually, wastewater is fascinating, very interesting. But tap water, obviously, too. So my pitch here is to consider the water business as a career choice. Consider it. Think about it. At the career fair, go see our people. Why? One reason I joined this, I was recruited from PG&E into this position. And there's a few reasons that I really was interested in this job. One was I like the people in the business, first of all. It's really fun. And not just Cal Water, but everybody in the business. It really is a service mentality. I want to serve the public. I mean, it's really a public service business. Private companies and the municipal side, the public side. But so I enjoy the people. It's really fun. A lot of smart people. The work we actually do in the field, and I'll show a couple of pictures, the work we do is fun too. It's kind of a frustrated engineer. I get to do these fun things in the field. And you're doing something that is a good thing, serving people, making the quality of life better for the customers you serve. So, this is essential, obviously essential utility, public for life and public health. And we are always improving our treatment, improving our water quality, even though it meets all the standards. So we're always improving our systems, and that is improving the quality of life. Let me tell you, it's so much fun to take a small, crummy system, and I won't tell you where they are, but we've taken many on in California and the other 3 states, to take a small, crummy system that's unreliable water that's not meeting standards and fix it up, invest in it, put our expertise in, and give those customers safe water to drink where they didn't have it before. That is really fun to do. I won't tell you where those places are, but we know where they are. And if you're not just in the US, obviously developing countries, you can make a huge impact on people's quality of life. Technology. This is an engineering school. Water quality is critical. We need new treatment technologies, more technology applied all over for water quality. And every discipline is needed. I mentioned this. I'm a mechanical engineer, but we hire electrical, mechanical, civil, chemical, IT people, business majors, accounting majors, you name it. Pretty much every discipline is needed in this business, not just with us, but with all the other companies. And lots of interesting projects. And we have a few slides of projects. Here is, this is our Visalia water system. It's all groundwater, all served by our wells. And we have hydraulically modeled all of our systems using GIS. So each point here is a node where there's a connection. And this is a blow-up of a small section where you can see the actual underground pipes and sizes. And so using this model, we can model anything. If you were to put a well in to make the system have more pressure, If you lose a well, what to do about that? If you have a water quality issue in a well here, how's that going to impact everybody else? It's amazing what you can do with the hydraulic modeling. Very, very technical. Run any scenario, water quality, supply, pressure, anything. This is underground. Now we're going to underground. You think, well, it's just a pipe. But the technology is there, and we're using it to actually, I mean, it's very, very expensive to trench into a street and replace a pipe, mainline distribution, or conveyance system with digging a trench. So we use this technology that's called pipe bursting. So you dig down, find the pipe, and then you go through with this kind of, it's like a mole or a tunneling machine, and you remount the pipe that's there and you pull it through a larger pipe without doing any trenching work. All GIS, all computerized. So that's fun to watch, very interesting. Supervisory control and data acquisition, which actually was a term I learned also in the engineering school. But we are monitoring and controlling all of our systems electronically. You can sit at a laptop in your garage and run our systems if you had access. So you see storage, what the status of the storage is, what the pressures are in the system, turning off, on and off pumps. Pressures, what are the pressures, what's the water quality standards, how is that going? All this is all computerized, and we can monitor and control our systems remotely. Not everybody can do this. A lot of those systems that need technology cannot do this yet. This is our largest treatment plant. It's in the city of Bakersfield. $49 million plant. Taking water from the Kern River. Very high tech, very clean water coming out of this. It's the quality of desalinated water. It goes through very thin membranes. This was built 5-6 years ago. If I took this picture today, there'd be houses all over the place. Because we were allowed the city to expand in the northeast quadrant just by virtue of this plant. Very, very fun project, actually. And then this is another one of my favorites because it's close to where I live. This is our reservoir, which is about 30 minutes north of here in Atherton. We have 1,100 acres of watershed in Woodside. And actually, we have on our watershed, on our property, the oldest and largest redwood tree in the county that we protect. Water comes from the watershed into this reservoir, 35-acre reservoir on 100 acres in Atherton, and then is treated through our treatment plant there. So you can see it's pretty picturesque. It's got some beautiful facilities. A lot of largemouth bass in there. So that's it. This is the wrap-up slide. Opportunities for everyone. We are always recruiting, and then not just we. San Jose Water is always recruiting all these disciplines. Santa Clara Valley Water District, huge organization, very, very sophisticated, lots of employees, as well as the cities, San Francisco, and the smaller cities who have water departments, and the state. The state needs a lot of help, engineering, a lot of technical help, because that system has got to be completely overhauled around the Delta. So lots of good organizations within a half-hour drive of here, running water systems, hiring people, lots of opportunities. So please give the water profession your consideration when you're thinking about a career choice. We'd love to have you. Time for questions. Thank you.
So on the issue about the Delta, and you're supporting for voters to vote yes on the proposition of moving the inlet above the Delta, why would someone argue to vote no? Okay,
if you didn't hear the question, you have to read the ballot measure because it's not on the ballot yet. So, can I go back to this? I'm going to try to go back here. I'll get there. There. This is the tug of war I mentioned. So for me, from a people and ecosystem point of view, this makes the most sense. Change the intake point from here to here. If I'm a farmer in the Delta, one of the 60 farms, my farm is protected by levees, 1,000 miles of levees. And actually, my farm is now 20 or 30 feet below sea level because they've subsided. So if there's a break in a levee, or two, earthquake, or just a failure in the levees, my farm is underwater. And so I really want the investment to go to the levees, not so much a conveyance system. So that's kind of part of the tug of war. There's always the argument of it's too expensive, too much money. I think that's the main one, though. And will it really save the ecosystem? Because you want to do two things here in the Delta. One is restore the wetlands, restore the ecosystem. Second is provide water going down the aqueducts. So that's where it gets complicated. As you know, it's people who are going to come out in opposition. That's why probably the proposition on the ballot is going to have all kinds of things on it, not just the conveyance system with the storage.
Earlier, you said that there was that when you have a finite supply of water, when there's a finite supply of water here in California, the population increases. I want to know if the opposite is true.
Which opposite would be?
Opposite would be if there was like an infinite supply of water, would the population decrease?
If there's an infinite supply of water, would the population decrease?
Yeah. Is the opposite hold true? That's what I mean.
I don't think so.
No?
No, I think, people and the economy and ecosystems use water, and as those grow and the needs are greater, you're going to need more water to be used.
Yeah.
And you have to find it somewhere. Either being more efficient, agriculture or people. Actually, the state is 96% self-sufficient in water. Only 4% is imported. Yeah. And that's from the Colorado River down here. Only 4% of our usage comes from Colorado River. I'm sorry? It's down here. It comes across here. There's kind of two aqueducts. It's interesting to me, of all the water that comes in from the Colorado River, 3/4 of it stops in the Imperial Valley for irrigation. It doesn't, only 1/4 gets through to people in the LA Basin and San Diego. Oops.
Is there anything being done to utilize ocean water?
Great question. My God, look at the supply you've got here. There are, I forget the number, I think there's 20,000 desalination plants in the world. Over half of those are in the Middle East. So someday this will be a supply source. Right now it's way too expensive and difficult to permit. There are some plants under construction, well, under development, I'll say, down here, which you would expect them to be. Major plants that basically take seawater and force it through a membrane and then produces tapping water on the other side. Very energy intensive to do that. So if we had new technology, better technology to desalinate the water, it would make this ocean available for supply, and that would go a long way to solving our supply problems. But in order of magnitude, what it costs, if you put in a desalination plant, $1,500 an acre foot for the water. If we buy it from these guys coming in this way, $900. If we make it in our wells, $300. So at this point, desalination is not economic. But someday, in the Middle East it is, someday it may well be economic.
Thank you very much for the presentation. So my just quick question is, in the coming age of the climate change is a real thing, it's happening all over the world, especially in California. And I was just wondering, how do you, what kind of some specific actions do you take to successfully adapt to the climate change issues in California, and especially in Northern California part? And then what would be the major challenges or advantages as a private company or private water supply company compared to public water supply company?
For climate change reasons?
Yes, or taking some specific other actions for successfully adapt to other random variables.
Okay, I'll try to answer the question, and I'll put it around climate change. I think that's a good place to start. As I mentioned, the precipitation, I'll use California. Precipitation happens generally in the northern and in the mountains, Sierra Nevada mountains, and a large storage facility for us is the snowpack in the Sierra Nevada. We count on that. There's dry years, there's wet years, but on average, it's a huge storage facility for all the people in the state. If the snowpack diminished, or if it came early or late, or if it melts quicker, that changes all the assumptions here for planning. Now, all of a sudden, you generally need more storage. Because pipelines move water over distances, storage moves water over time. And definitely be a time issue immediately. So that may drive more storage. Who knows? It may make this source more economic. Hard to say. But definitely there's a large range of scenarios for planning. Yeah. And mostly public agencies. These are huge. This is the state of California and the federal government. This is their system, basically, operated by the state. So from a 1,000-employee customer of the state and federal projects, we influence them to plan and build these facilities and try to help people make the right decision politically. But in the end, we're at the end of the pipe.
Yeah. Actually, you told for a water company, infrastructure is important and employees are important. Moreover that, first of all, you need the water to purify it. So, because so many companies are doing the same thing, how they can share the water source? Are there any government regulations? Some water has to go to this company and some other water has to go to other company?
Great question. How is the water divided up? How do we know what's our water? We don't really own water. Water is a natural resource, so we'll take it, make it safe to drink, disinfect it, treat it, and then deliver it to customers, and then they use it. In some areas, and I'll use the Los Angeles Basin as an example, where there's groundwater, there's an aquifer, 2 aquifers in fact, that were overpumped for years. And then in about 1950, 1955, we, meaning the industry, realized the aquifer is dropping and this is not a sustainable way to do this. And so what has happened in the LA Basin, each of the people who use water have a certain right to a certain amount of water. And they can't go beyond that right. And the right that they have, when you add them up together, that allows the aquifer to be sustainable. And as in Santa Clara Valley, in the LA area, we are spreading groundwater to let it go down to the aquifer to keep it sustainable. So you really want to make sure, because you have to plan into the future forever for water supply. And you want to make the sources you have sustainable forever, basically.
One last question.
I recall you were saying that in the next 20 years for California, we will need $336 billion.
Oh, I'm sorry. That's U.S.-wide.
Oh, entire U.S. Okay.
Yeah.
Okay, that's fine.
Yeah. I could spend it, but I don't think we need it.
I'm assuming you guys retreat wastewater. What's your feelings on using wastewater as drinking water?
Good question. It's more of a emotional, political decision than it is a technical one, because we can, and our wastewater systems are basically in New Mexico and Hawaii, and we can treat that water effluent to drinking water standards. But there's definitely an emotional block for people to accept that. So in all our systems that we use, that we recycle the water, it goes to irrigation. Basically golf courses, large industrial plants to irrigation outside. It does not go to drinking water source. Some areas of the world different, where water is very expensive and they need to use the effluent treated drinking water quality. That's a different situation. But in California, U.S., we haven't made that leap yet of showers to flowers now. Thank you. Thank you.